Hello again, year 11. You probably recall last lesson we were taking the equation of a curve and drawing in some lines that solved a very similar equation. Some questions where we had to manipulate the algebra slightly in order to know where to place that line. But one thing you'll have noticed about last lesson is every single additional line we drew on the graph was a horizontal y equals a number line. Now, with some equations and some manipulation, we're going to find that we get a graph that is a straight line of the form y equals mx plus c. So we're going to be looking at how we can adapt to the maths that we did last lesson for slightly more challenging equations. But before we get started, let's see if you can recall how to use the quadratic formula to solve a quadratic equation. You will need your calculator unless you're desperately keen to write something in third form, but I guess I could do both, couldn't I? So what I would suggest you do is you pause the video here, give yourself 2 or 3 minutes. I've given you the formula to substitute into, but don't forget you would need to learn that formula. So then I challenged myself to see if I could do this as a third. You've also noticed I've found my calculator so I could maybe do the answers to 2 decimal places or 3 significant figures. So let me write down what my A, my B and my C are. So A is the coefficient of x squared, that's 1x squared. B is -2 and C is also -2. So let's substitute into the quadratic formula. Well, I need minus b. If b is -2, minus b is 2. Minus 2, 2. Then I've got my plus or minus. I need to do b squared, so -2 squared, minus 4 times a times c, which would be 4 times 1 times -2, all divided by 2a, which is 2 times 1. I'm going to tidy up as much of this as I can before I even reach my calculator. So it's 2 plus or minus, well, -2 squared, -2 times -2 is +4. Subtract, I'm going to do 4 times 1 times -2, and that is -8, all divided by 2. If I then tidy it up a little bit more, under the square root is the square root of 12, all divided by 2. Since I challenged myself to do this as a third, root 12 is the same as root 4 times root 3, which is 2 root 3. So this is going to tidy up amazingly, because it is 2 plus or minus 2 lots of root 3 divided by 2. So I can divide this by 2, I can divide this by 2, it all cancels to 1 plus or minus root 3. But what would that be as a decimal? Well, let's just take a quick look. So I've got 1 plus root 3. This will give it me as a third, I'm sure. Yeah, 1 plus root 3. I'll turn it into a decimal. So to 2 decimal places, I've got 2.73. Scribble it up here, 2.73. And that was my positive answer. And for my negative answer, 1 minus root 3 is negative 0.73. So negative 0.73. So hope you got that right. If you challenged yourself with the thirds, did you spot that root 12 cancelled? So for today's lesson, I hope you've managed to print out a sheet, a note sheet that will speed things up for you. If not, you've got a couple of options here really. You could copy some of the main maths down and draw one of these diagrams or one of these examples out, or perhaps maybe wait for an opportunity when you can print out the graphs and just leave some space to stick it into your book. So, as I alluded to in the introduction, we've only looked at some questions so far where we've had to plot some additional horizontal lines onto our graphs. However, today we are going to be plotting some y equals mx plus c graphs. I'm not going to be drawing tables of values for these. I'm going to be just working out a couple of coordinates and plotting them quickly. So I am going to be making the assumption that you are confident plotting a straight line graph. Other than that, the maths that we're going to use today is very similar to last lesson, in order that we are going to be manipulating the equation that we are given into the form of the equation of the graph. So I have given us the graph y equals x squared take away x plus 2, and we are going to use it to solve the quadratic equation x squared take away 2x take away 2, which incidentally is the quadratic equation we solved just a moment ago. So we already know the answers to that, and we can use this as an opportunity to double check that this method is working. So remember, the equation that we're trying to get to is the equation of the graph. And the equation of our graph is x squared take away x plus 2. So you need to think about, well, how can I manipulate this into the graph that I've got? What will happen to the other side? So what am I missing? Well, I'm starting with negative 2x's, but I, in my graph, have negative x. So I'm going to need to add an x. That will get me from minus 2x to negative x, which is my graph. How am I going to alter the number from negative 2 to get it all the way to plus 2, which is my graph? I need to also add 4. So, what does this part of my equation become? I'm going to need x plus 4. So the equation of the graph that I'm going to draw is y equals x plus 4. Well, we'll know it'll go through 4 because it has an intercept of 4. Now, you might be thinking, oh, it's going to be a 45-degree angle, but it isn't, because the scale on my axes isn't the same. So we could work out some other points. When x is 2, y is 6. So it's going to go through 2, 6. Could also do the same here. When x is negative 2, it's going to go through 2. You plot these as carefully as you can, because I have already got the graph ready. So there is my equation of y equals x plus 4. And to find the solutions to the equation that I'm trying to solve, we just need to see where these two graphs now intersect and read off the corresponding x values. So I can see I've got an x value, looks to be about 2.7 if I'm trying to do it to one decimal place. So that's one of them. And it looks like we've got about negative 0.7. Take a look back at your answers to the starter activity. Those were the two answers that we got using the quadratic formula. Let's have a look at this next equation and see if we can manipulate it into the equation of our graph. So we need to get it back to our graph, and let's remember our graph is x squared take away x plus 2. So how can I manipulate the equation that I've got into the graph that I have plotted? Well, to go from negative 4x to negative 1x, I'm going to need to add 3 x's. And to go from 1 to 2, I'm going to need to add a 1 as well. So altogether, I have added a 3x and a 1. So the graph that I need to plot is y equals 3x add 1. So again, where's that going to be? Well, we know it'll go through 1 on the y-axis. We then need a gradient of 3, but you could try substituting some other values in. When x is 1, y is 4, so it's going to go through 1, 4. When x is 2, y is 7, plot 2, 7. But once again, I've already got my line prepared. So there we've got y equals 3x plus 1. We need to see what are the x values where this intersects with my curve, because they will solve the original equation. So we can see we've got two values again. We've got about 0.3. So I'm going to put 0.3. And what's my other solution? It is 3.7. Let's look at the other graph. So this time I've got a negative x squared graph. Remember, this is still a quadratic graph, but a negative x squared isn't a U shape, it's an N shape. So I've said use the graph of y equals 10 take away x squared to solve 10 take away x squared. So how am I going to get back to the graph that I've got? I don't have any x's here. I need to get rid of that x, and I can get rid of that x by adding x. So this side of my manipulated equation becomes x. So there's the graph that I've got. I'm going to need to plot the graph of y equals x. And again, it isn't going to be that straightforward 45-degree diagonal because of my axes. We need it to go through 1, 1, 2, 2, 3, 3, and so on. So there is my y equals x graph. So where does it intercept my curve? Let's have a look. It looks like a value of about 2.7 and negative 3.7. Now, if you're starting to feel a little bit confident, you could pause the video here, see if you can have a go at this last question yourself. Perhaps use a pencil. If you're not feeling confident, just carry on listening to me. So we've got this final equation, 8 plus x minus x squared equals 0. Remember, we need to manipulate it into the graph that we've got. Well, I can see I'm going to need an extra 2, and I'm going to need to subtract that x. The negative x squared is fine. So if I'm adding 2, I'm going to have 2, and if I'm subtracting x, I need to draw the graph of y equals 2 minus x. So remember, that will go through the y-axis at 2. That's the intercept. And this is a gradient -1, so it's going to be sloping down. Something like that, cutting the x-axis at 2 as well. Because when x is 2, y is 0. So let's draw that one in. So finally, where does this intercept my graph? Well, it's there, and it is there. So let's read off those x values. And we can see we've got an x value of what looks to be about negative 2.3 or 2.4. It's fairly in the middle. I think it's marginally closer to negative 2.4. And this one here, again, looks marginally closer to 3.4. Now, for the questions that you try today, in question 4, you do not need to draw any graphs whatsoever. You are just working out the equation of the line that you would plot. In question 5, a lot of the lines that you need might already be drawn for you. you might still need to put some horizontal lines in like last lesson. What I will say is if you are feeling adventurous and you really want to have a go at one of these where you are doing everything for yourself, then I would suggest you look at question 9. I'll link in the resource for graph paper again, just in case you need some. But I think you'll appreciate, because there are diagrams already drawn for questions 5 and 6, and the fact that you're not drawing anything for question 4, I've picked some nice questions for you to try today. As always, there are answers at the end, so please check your answers before uploading images of your work. And as always, if you need to ask any questions, I will be available in the Ask the Teacher channel.